Good morning. I am Seshagiri Rao, Associate Professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering College. I am going to now demonstrate the experiment of common source amplifier using CAD software. So here in the common source amplifier, we are using the N MOSFET as a amplifier, and N MOSFET works as amplifier in the saturation region. So I have created instance from the GPDK 180 library, the N MOSFET, and I have positioned it here. Similarly, I have taken the instance of the P MOSFET from the GPDK 180 library and I have positioned it here. And from the analog library, I have taken the VDD and the ground lines, and these I have positioned them here. And the VDC, I have taken it as 1.8 volts. You can see here in the properties that VDC is 1.8 volts. So this is how I have taken 1.8 volts. Next, I have taken the input voltage from the V sine source. So I have taken this V sine source from the analog library, and this is a V sine source which simulates the sine wave signal, and the sine wave signal frequency is 1 kHz, as you can see here. The amplitude is 500 millivolts. The DC voltage is 0 volts. So this is the voltage which is applied at this point for amplification. And these are the pins, input-output pins, which I have taken from the analog library. So these are the input-output pins. So this the pin name is VN, and it is a signal and it is input pin. Similarly, this is the output pin V out. So you can see here this is a V out and this is the output pin. And for the simulation, we have the different environments. We have ADEL, ADEXL, ADEGXL, and we are going to use ADEXL environment. And in ADEXL, okay, as this frequency is 1 kHz, the period is going to be the 1 millisecond. So I am going to consider the transient response for 0.5 milliseconds. As you can see very clearly, this is 0.5 milliseconds, and the analysis we have three variables: moderate, conservative, and liberal. So I have taken the moderate analysis for 500 microseconds, and I am going to plot. I have taken the output variables as Vin and Vout. So you can see here outputs Vin, and that is selected for plotting with a red tick mark, and Vout also has been selected with a red tick mark. So after getting this, I have to press this green button. So now I am pressing this green button. Now I am getting when I press the simulation, I am getting this sort of response. This is Vin. So you can see very clearly Vin, and the frequency is 1 kHz. The frequency is 1 kHz, and this is the amplitude. Okay. So you can see here the frequency is 1 kHz. That means this is 0.0 and this is 1.0, and here time unit is milliseconds. So that means this is 1 millisecond. So I am getting the V out net. So this is a V out net, the amplified output, which has come at this voltage level. You can see very clearly that the voltage is amplified. And please note this point that in common source amplifier, the phase difference between input and output is 180 degrees. So when this is maximum, the input is minimum. And when input is maximum, the output is minimum. So this is the input is maximum, and you can see very clearly the output is minimum. So there is a phase shift of 180 degrees. There is a phase shift of 180 degrees. So why it is called common source amplifier? Because the input is applied between gate and the source, and output is taken from the drain and source. Then you can ask, what is the role of this transistor PMOS? See, PMOSFET gate is connected to ground. So when PMOSFET gate is connected to ground, you know that the gate voltage is 0 and this is always on. So this acts like a dummy load and it acts like a resistor. And a bias voltage of minus 1 volt is applied to the source of N MOSFET. So this is a minus 1 volt. You can see here the properties. This is minus 1 volt. So minus 1 volt has been applied here, and the output is taken from this point. So output is taken from the drain and source, and input is applied to gate and source. So you can see very clearly that the source is common to input and output. That is why this is called as the common source amplifier. This is similar to common emitter amplifier, where in common emitter amplifier also we get a phase reversal of 180 degrees between the output and the input. So you can make a note of this. So with this, we conclude the simulation and verification of common source amplifier. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.